In September of 2009, a team of paleontologists arrived at an open-pit coal mine in the far north of Colombia. The place is called Cerrejón and is one of the largest coal operations on Earth. For years, the mining trucks had been hauling out something nobody was paying attention to: dark, curved shapes embedded in the sediment, chunks of rock that almost looked like giant ribs. When the scientists finally examined them, the numbers stopped feeling real. They were vertebrae, snake vertebrae, each one nearly the size of a dinner plate. When the animal was reconstructed piece by piece, in a Florida laboratory, it stretched to more than 40 feet in length and weighed over a ton. Its body was thicker than a grown man's torso. They named it Titanoboa. And that snake, terrifying as it is, was only one entry in a much longer catalog, the one this documentary is about. Because if you believe the deadliest animals in the history of the planet are the ones alive today, you have the timeline exactly backwards. For most of Earth's history, the top of the food chain has been occupied by creatures that nothing living can match. Not in size, not in speed, not in the sheer engineered violence of their anatomy. Great white sharks, saltwater crocodiles, tigers, the largest bears on Earth, every one of them would rank as a moderate, mid-sized predator next to the monsters that came before. And that fact is not a curiosity. It is very possibly the reason you exist. Consider one number before we go any further. Anatomically, modern humans have been on this planet for roughly 300,000 years. Titanoboa was already gone by the time our lineage began, but not by much on the scale we're about to work in. 60 million years is a long stretch, and yet it is only the last 1% of the story we're telling tonight. In the 99% that came before, the Earth was almost continuously ruled by monsters. Some of them died out 300,000 years ago, which in geological terms is essentially yesterday. Others survived long enough to see the first human hand axes chipped from stone. The idea that our world is a dangerous place is, from the perspective of the fossil record, almost funny. This is a documentary about 10 of the most nightmarish creatures ever confirmed by the fossil record, and the question I want you to keep in mind as we go through them is not how large they were. That's the shallow question. The deeper question is, what would our world look like if any of them were still around? Because these animals didn't simply vanish. Each of them ruled an ecosystem so completely that when their reign ended, entire branches of life were rewritten. Snakes shrank, reptiles retreated, mammals rose, primates emerged, and eventually a soft-skinned, slow-running, tool-using species walked upright out of the African savanna into a world that had been carefully, patiently cleared of its worst predators. That species was us. Over the next 40 minutes, we are going to walk backwards through deep time. Through the coal swamps of the Carboniferous, through the deserts of the Permian, through the final age of the dinosaurs, through the drowned tropical world of the Paleocene, through the isolated continent of South America, all the way up to the Ice Age. At every stop, there is a monster. Some of them died in mass extinctions. Some of them starved into oblivion when the climate turned against them. Some of them, quite possibly, were hunted to death by our own ancestors. What connects them is that none of them made it. What I want you to notice as we go is how narrow the margin actually is, how close some of these creatures came to overlapping with human beings. A quick word about the sources before we start. Everything you are about to hear is drawn from the published paleontological record, from peer-reviewed descriptions of the fossils, from the field notes of the researchers who unearthed them, from the reconstructions built and displayed by the museums that hold the specimens. Where the science is genuinely uncertain, I will tell you. Where estimates differ, I will give you the range. And where a claim has been sensationalized in popular culture in a way the evidence doesn't support, I will flag that too. This is a documentary about real animals. The fact that they sound invented is only a measure of how strange the deep past really was. If this kind of investigation is the sort of thing you want more of, take a second right now to hit like and subscribe. It tells the algorithm to keep sending it your way. Let's begin at the bottom of the fossil record, in a world that was not yet ours, and work our way forward. Go back 300 million years. Not 300,000, 300 million. If you were somehow dropped into that world, the first thing you would notice is that you couldn't breathe properly. You would be lightheaded, almost drunk. That is because the air of the late Carboniferous period was radically different from ours. Modern Earth's atmosphere is around 21% oxygen. In the Carboniferous, most reconstructions place it above 30% and possibly as high as 35%. The planet was covered in dense, wet, primeval forests, Enormous fern trees, club mosses the height of skyscrapers, swamps that would later compress into every coal seam on Earth, including the one that Cerrejón sits on. All that vegetation was pumping oxygen into the sky faster than anything could burn it off. And with that much oxygen came a very specific biological consequence. Insects and their relatives, the arthropods, do not breathe with lungs. They breathe through tiny holes in their exoskeleton called spiracles, and oxygen has to diffuse passively through internal tubes to reach their tissues. That system works fine at small sizes. At larger sizes, it fails because the tubes can't move gas fast enough. This is the reason a modern beetle can be the size of your palm at most, and no larger. But raise the oxygen level of the atmosphere by 50%, and suddenly that ceiling lifts. Suddenly, arthropods can be huge. The Carboniferous is the moment they were huge. And the two creatures that came out of it are, by nearly any measure, the most disturbing invertebrates that have ever existed. The first is called Arthropods. Fossils and preserved trackways of this animal have been found across what is now Europe and North America. At its full adult size, Arthropods reached about 2.5 meters in length, and some specimens are estimated to have approached 3. That is 8 to 10 feet of segmented, armored millipede walking on dozens of pairs of legs through the forest floor. The reconstruction on display at museums in Germany and the United Kingdom is genuinely difficult to look at for long. It is not a creature that reads as prey. It reads as a slow, patient armored tank. What it ate is still debated. Some paleontologists argue it was a strict vegetarian, grazing on the ferns and fallen wood of the coal swamp. Others point out that the mouth parts are compatible with scavenging or opportunistic predation. The honest answer is that we don't fully know. What we do know is that almost nothing in that ecosystem was big enough to threaten it. The second creature that came out of the same oxygen-rich window is worse, and I mean that specifically. It is called Pulmonoscorpius, and it is exactly what it sounds like. A scorpion, but not one you can flick off a shoe. Pulmonoscorpius grew to a length of about 70 centimeters, over 2 feet, with the same body plan as a modern scorpion. Grasping claws at the front, a segmented tail curled over the back, a stinger at the tip of that tail, and crucially, air-breathing lungs, which is where the name comes from because it means this thing could walk out of the water and hunt on dry land. Whether its venom was as potent as some modern scorpions is not directly measurable from a fossil record. Venom rarely fossilizes, but the delivery apparatus is preserved beautifully, and it is enormous. A single strike would have injected a volume of toxin that any small vertebrate of the period simply could not have survived. I want to pause here because it is easy to picture these animals as isolated freaks. They were not. The Carboniferous was full of oversized arthropods. Dragonfly relatives called Megalodon patrolled the air with wingspans over 2 feet. Cockroach-like insects were larger than a modern rat. If you set foot in that forest, you would not encounter a single monster and then get away. You would be in a forest that was almost entirely constructed out of them. Everything in your peripheral vision, from the leaf litter to the treetops, would be some form of segmented, chitinous animal at a scale nature no longer allows. And then, at the end of the Carboniferous, that entire world collapsed. The oxygen levels dropped. The great coal forest wetlands dried up. The arthropod giants shrank, then disappeared. The stage was cleared for something new, something with a backbone. Which brings us to our next monster, and to a period of Earth's history that most people have never heard of, but which produced one of the most nightmarish predators in the fossil record. The Permian period is one of the strangest chapters in the history of life on Earth. It ran from about 299 million to 252 million years ago. It is the period that came directly before the dinosaurs, and it ended in the single largest mass extinction the planet has ever experienced, an event so devastating that geologists nicknamed it the Great Dying. Somewhere around 95% of all marine species went extinct. Roughly 70% of land vertebrates went extinct. Entire ecosystems collapsed and had to be rebuilt from what little survived. And in the millions of years before that ending, the Permian was ruled, on land, not by anything reptilian in the way we think of reptiles. It was ruled by a lineage called the synapsids. And the top predator of that lineage was Gorgonops. You may never have heard the name, but you have almost certainly seen a picture of one, because paleoart tends to reach for Gorgonops any time it wants to illustrate the Permian. The animal looked at a glance like a dog crossed with a lizard, except larger. Estimates for the largest species put the body length at about 3 meters. The skull was long, low, and heavy, built like a wolf's, but bigger. The legs were held somewhat under the body, giving it a fast, mammal-like gait rather than the sprawling posture of a modern lizard. And the teeth were what stopped people. Gorgonops had a pair of massive canines in its upper jaw, canines so long that, in some specimens, they protruded past the closed lower lip. Saber-teeth, essentially. 260 million years before the saber-toothed cats of the Ice Age, this animal had already invented the design. I want to underline the point about the lineage, because it matters for the whole story we're telling. The synapsids are technically our ancestors. Not our direct ancestors. Gorgonops itself is a side branch, but the same broad family that eventually gave rise to mammals and eventually to us. If you had walked through a Permian floodplain and seen a Gorgonops from a distance, you would not have been looking at a reptile in any modern sense. You would have been looking at something closer to a very early, very violent great-uncle. The fossils show muscular attachment points along the ribs and hips that are consistent with active hunting. The wear patterns on the canines are consistent with regular use on prey with bone. This was not an ambush lizard sitting in the sun. This was, by the standards of its time, a wolf. And that raises a hard question that paleontologists have been arguing about for decades. Because Gorgonops was, on paper, a mammal relative. Was it warm-blooded? Did it have fur? Did it care for its young? The direct evidence is limited. Fur and metabolism don't fossilize, but the indirect signals lean toward yes, at least partway. Bone growth patterns in some synapsids of this period look surprisingly mammal-like. Nasal cavity structures suggest respiratory turbinates, a feature associated with endothermy, which means Gorgonops was not just larger and toothier than most modern predators. It was possibly warm-blooded, possibly furred, possibly social, and it was tearing apart animals the size of pigs on a Permian afternoon 260 million years before humans learned to walk upright. Then it died. All of them died. When the end of the Permian arrived, driven by an unimaginable pulse of volcanism in what is now Siberia, releasing carbon dioxide and sulfur into the atmosphere on a scale we can barely simulate, the synapsid dynasty was almost entirely erased. A handful of small survivors slipped through into the Triassic. Everything else, including every Gorgonops on the planet, was gone within a geological blink. And here's the part that should stay with you. The branch that survived, the one that eventually became mammals, spent the next 150 million years as small, nocturnal, forgettable creatures, because the reptiles that filled the emptied ecosystems very quickly turned into dinosaurs, and dinosaurs were not going to share. If Gorgonops had made it through, if that synapsid dynasty had continued unbroken, the age of reptiles might never have happened. And mammals, us eventually, might never have gotten their opening, which is a strange thing to sit with. One of the most nightmarish predators in fossil record was, technically, on our team. Now jump forward almost 200 million years, all the way to the end of the Cretaceous, and change environments completely. Come out of the forests and floodplains. Go under the surface of the sea. Because for the last stretch of the dinosaur era, the deadliest thing on the planet was not walking anywhere. It was swimming, and it was doing so at a scale that modern oceans no longer contain. Its name is Mosasaurus. And I want to correct something before we go further, because popular culture has done this animal a very specific kind of damage. If you saw Jurassic World, you saw Mosasaurus. It was the creature in the huge aquarium tank that leapt out of the water and ate a great white shark on a hook. It's the same animal that later, in the same film, eats a much larger predator that we will get to shortly. The problem is that the movie's Mosasaurus is scaled up to somewhere around 50 meters long, which is a wild exaggeration. The real animal was about 17 meters, or roughly 56 feet, at the top end of confirmed estimates. That is still enormous. It just isn't the size of a nuclear submarine. And the real facts about this creature are frightening enough that no exaggeration is needed. Mosasaurus was not a dinosaur. That is a common confusion, and it's understandable because it lived in the same age as the last of them. But taxonomically, mosasaurs are marine lizards. Their closest living relatives are, arguably, monitor lizards, the family that includes the Komodo dragon. Imagine a Komodo dragon, if you can, evolved back into the ocean, given a paddle-shaped tail, given flippers instead of feet, given the ability to give birth to live young in open water, and then scaled up to the size of a small whale. That is roughly what Mosasaurus was. The head alone, in the largest specimens, is more than 5 feet long. The jaws are lined with rows of conical, backward curving teeth. And here is the detail that most people miss. They had a second row of teeth on the roof of the mouth. Anything they closed on, they held. Anything they held, they swallowed. The Mosasaurus was, in the last few million years of the Cretaceous, at the very top of the marine food chain. It preyed on smaller mosasaurs. It preyed on large sharks. It preyed on the ammonites, the coiled-shelled cephalopods that fossilized by the millions in Cretaceous rock. Many ammonite fossils have puncture wounds in the shell that match the tooth pattern of a mosasaur bite. It preyed on plesiosaurs, the long-necked marine reptiles that most people picture when they hear the words Loch Ness Monster. Fossilized stomach contents have shown mosasaur remains with sea turtles inside, whole. There is no evidence that anything hunted Mosasaurus. Nothing in its ecosystem was big enough to try. And then, 66 million years ago, an asteroid roughly 10 kilometers in diameter struck the shallow sea near what is now the Yucatan Peninsula in Mexico. The initial impact vaporized everything within hundreds of miles. The shockwave, the wildfires, the sulfur injected into stratosphere, the years of impact winter that followed, that is the event that killed the non-avian dinosaurs. And it also killed Mosasaurus. The oceans, cut off from sunlight by atmospheric dust, saw their phytoplankton collapse. The food chain unraveled from the bottom up. The largest predators, requiring the most food, went first. Mosasaurus disappeared with everything else. But before we leave it, take a second to sit with this. If the asteroid had missed, if it had come in at a slightly different angle, or if it had struck deeper ocean where the sulfur payload would have been smaller, the mosasaurs might still be here. And the oceans of a modern Mosasaurus world would not be swimmable. Fishing industries would collapse. Coastal populations would retreat. The Jurassic World sequence, the one where the audience gasps because a huge lizard eats a shark, would be an ordinary summer news clip from an Australian beach. Everything we take for granted about the modern ocean, that you can more or less swim in it, is dependent on the fact that a rock the size of a mountain hit the planet at exactly the right moment. And that is only the first of two Cretaceous nightmares we need to look at, because the sky, at the same time, had a monster of its own. Look up. The sky, in the same final stretch of the Cretaceous, was not empty either. And what was in it is, for a lot of people, the single most disturbing animal in the entire fossil record. Not because of teeth, not because of size exactly, but because of proportion. The animal is called Quetzalcoatlus, named after Quetzalcoatl, the Aztec feathered serpent god, because when its discoverers first pieced the skeleton together in Texas in the early 1970s, they were not sure what to compare it to. Nothing living looked anything like it, and in a real sense, nothing living ever will again. Quetzalcoatlus was a pterosaur, which is not a dinosaur and not a bird, but a separate group of flying reptiles. Most people think of pterosaurs as small, gliding animals, the little leathery things with narrow wings that you see in dinosaur illustrations. That is what most pterosaurs were. Quetzalcoatlus was not most pterosaurs. When it stood on the ground, it stood roughly the height of a giraffe. Let that sit for a moment. Not a giraffe cartoonishly rendered, a real, adult African giraffe. Modern estimates put its shoulder height at about 3 meters, its total standing height, with the neck erect, at around 5.5. Its wingspan, when it opened those wings, is estimated at between 10 and 12 meters. Some earlier reconstructions went higher, to 15. That is the wingspan of a small commercial aircraft. But what makes Quetzalcoatlus disturbing, more than the size, is the geometry. Because for decades, when this animal was first described, it was assumed to be a soaring, ocean-going predator, a kind of enormous albatross that skimmed the seas eating fish. That picture is now known to be wrong. Detailed studies of the bones, the muscle attachments, the neck vertebrae, and especially the trackways attributed to Azhdarchid pterosaurs, the family Quetzalcoatlus belongs to, have shown a very different lifestyle. This animal spent most of its time on the ground. It walked on all fours, using the folded wing fingers as front legs, in a posture that has been compared to a giant stork. And it did not skim the sea. It stalked the floodplains and the shallow inland waterways of Cretaceous North America, hunting on foot. Picture that for a moment. A creature the height of a giraffe, walking through a swamp on 4 legs with a beak 2 meters long and a neck long enough to reach into a nest, a burrow, or a river. Small dinosaurs, hatchlings, mammals, amphibians, fish, all of it on the menu. Whatever it grabbed, it swallowed whole, in the manner of a modern stork or heron. And nothing in the environment was really set up to fight back against something with that reach, because the reach was the innovation. Most terrestrial predators of the late Cretaceous were designed to close distance on prey. Quetzalcoatlus already had the distance from the moment it walked into view. A small mammal that spotted one from 30 feet away had already lost. A juvenile dinosaur that came out to drink from a floodplain river was, from the pterosaur's angle, effectively pre-caught. The debate over whether Quetzalcoatlus could sustain long-distance flight or was closer to a giant, mostly terrestrial animal that used flight only for short escapes is genuinely unresolved. Different groups of paleontologists have argued both cases in peer-reviewed papers within the last decade. What is not disputed is the size. What is not disputed is the walking hunting behavior. What is not disputed is that if you had been standing in what is now Big Bend National Park in Texas 70 million years ago, and you saw the silhouette of one of these things coming across the flats toward you, you would not have survived the encounter. And there is one more detail that makes it worse. Quetzalcoatlus went extinct in the same event as Mosasaurus, in the same asteroid impact, at the same moment 66 million years ago. So both the ocean and the sky were cleared at once. On a Wednesday, geologically speaking, the two most disturbing predators of the Mesozoic disappeared, and the Earth, for a very long moment, became almost quiet, which is when the next monster in our list moved in, and it moved in fast. We started this documentary in a coal mine in northern Colombia. Now, 6 million years after the asteroid, we're going to go back to it, because Cerrejón is not just any fossil site. It is the closest thing paleontology has to a window into the world immediately after the extinction. The rocks laid down there record what happened in the tropics in the millions of years after the dinosaurs were gone. And what those rocks show is very strange and very specific. They show a hot world. A world where average annual temperatures at the equator were around 32 degrees Celsius, roughly 90 degrees Fahrenheit. Modern tropical rainforests average about 26. That is not a small difference. That is the difference between a hot afternoon and a permanent heat wave. And in a world that hot, cold-blooded reptiles can grow to sizes that are otherwise impossible, which is where Titanoboa fits in, because Titanoboa is not a survivor from the age of dinosaurs. It is a post-dinosaur invention. It evolved in a world where the giant marine reptiles were gone, where the pterosaurs were gone, where the terrestrial dinosaurs were gone, and where the surviving lineages of snakes suddenly had ecological room and a climate that let them grow. Titanoboa cerrejonensis, as the species is formally named, is estimated at 42 to 48 feet in length and over 1,100 kilograms in weight. That is more than a ton. For scale, the largest confirmed modern snake, the reticulated python, tops out at around 33 feet at the extreme edge of the record and weighs a fraction of that. Titanoboa was not just larger, it was thicker. At its midsection, the animal was around a meter across, wider than a human torso. The hunting behavior can be inferred from the anatomy. Like modern boas and pythons, Titanoboa was almost certainly a constrictor. It killed by wrapping its body around prey and tightening. Modern boa constrictors kill by stopping blood flow to the brain, not by suffocation, as is often taught. The animal loses consciousness in seconds and is dead in less than a minute. Titanoboa, at roughly 10 times the mass of a modern boa, would have applied constricting force at a scale where almost no vertebrate could survive it. The fossil site at Cerrejón preserves alongside Titanoboa the remains of very large freshwater crocodilians and giant turtles, and the leading interpretation of the ecosystem is that the snake was preying on those. Not on land mammals, on crocodiles. That is what it took to keep an animal that size fed. I want to correct a common piece of misinformation here because it circulates a lot online, and it's simply wrong. Titanoboa did not eat human beings. It could not have. Human beings did not exist yet. 60 million years is a very long time, and no primate remotely resembling us was on the planet. What the science actually says is that a hypothetical human dropped into the Paleocene wetland of what is now Colombia would have been well within the size range of prey Titanoboa was capable of taking. That is a statement about the animal's physical capacity, not a statement about anything it ever did. I mention this because if we're going to have a documentary about nightmarish extinct animals, we should at least be honest about which nightmares happened and which are cinematic. Then, over the next several million years, Titanoboa disappears from the record. There is no single dramatic event that explains it. What the fossil record does show is that global temperatures started to fall from that Paleocene maximum. As tropical ecosystems cooled, the metabolic budget that allowed a cold-blooded animal to grow to 40 feet stopped balancing. The largest individuals could no longer sustain their body temperature. The population shrank in size, then disappeared. The lineage that survived is the modern boa family, which means every time you see a boa constrictor at a zoo, you are looking at what is left of the empire of Titanoboa. Now, let's leave the tropics of the Paleocene behind and move forward. Because there is a continent we haven't visited yet, and for tens of millions of years it was cut off from the rest of the planet, and it produced its own private line of monsters. For most of the last 60 million years, South America was an island. That fact does not get enough attention in popular history, but it is one of the most important facts in the story of mammalian evolution, because when a continent is isolated, its ecosystems evolve in private. The Panama Land Bridge, the strip of land connecting North and South America, did not close and become a continuous ecosystem until roughly 3 million years ago. Before that, South America drifted alone for tens of millions of years, and what it produced was, in a very literal sense, an alternate history of Earth. And two of the animals it produced belong on any honest list of the worst predators the planet has ever built. The first is Purussaurus. It was a crocodilian, the same broad group that includes modern alligators and crocodiles, but calling Purussaurus a crocodile is like calling a passenger jet a paper airplane. The largest specimens, based on skull material recovered from the Amazon basin in what is now Peru and Brazil, are estimated at around 12 to 13 meters in length. That is over 40 feet. Is more than twice the length of the largest saltwater crocodile alive today, which is already the biggest reptile on the planet. It lived roughly 8 million years ago, during the Miocene, in a vast wetland ecosystem that stretched across much of what is now the Amazon rainforest, a warm, slow, freshwater world of oxbow lakes and swamps and enormous freshwater turtles. Purussaurus's bite force, reconstructed from a skull anatomy, is estimated in some studies at over 80,000 newtons. That is, by a comfortable margin, the strongest bite force ever calculated for any animal, extinct or living. For scale, a modern great white shark is around 18,000 newtons. There is a legitimate debate in the literature about whether Purussaurus was fully aquatic like a modern crocodile or spent more time on land basking and ambushing. What is not in debate is that this animal was the apex predator of its ecosystem, and its ecosystem contained mammals up to the size of the largest rodents ever known, some of which, at the time, were also giant. Coexisting with Purussaurus were rodents the size of buffalo. Everything in this world was scaled up, and Purussaurus sat above all of it. If the Miocene Amazon had survived unchanged into the modern era, the river system would not be a tourist destination. It would be a no-go zone. But there was another predator in South America at roughly the same time that is, in its own way, even harder to look at. The forest racids, popularly called terror birds. These were flightless carnivorous birds that range from about a meter tall at the smaller and up to nearly 3 meters, 10 feet, at the largest species, Coelenchon guillermoi, whose skull alone measured over 70 centimeters. Terror birds ran on 2 long, powerful legs, and modern studies of their leg proportions suggest they were fast, possibly comparable in top speed to a modern ostrich, though the debate over exactly how fast is ongoing. What is clear is the hunting apparatus. The head of a terror bird was enormous, deep, and hooked like an eagle's beak, but at the scale of a large horse's skull. The current interpretation, based on jaw mechanic studies, is that terror birds killed by grabbing prey and repeatedly striking downward with their beak, like a giant, muscular pickaxe. Anything they caught, they dismantled. The isolation of South America ended about 3 million years ago, when the Panama Land Bridge closed. And that is when the story of both these animals shifts, because North American predators, big cats, saber-toothed cats, canids, crossed over. The competition changed. The climate cooled. The wetlands that had supported Purussaurus contracted. The mammal fauna that supported the terror birds shifted. Purussaurus was gone before humans arrived. The last terror birds hung on until roughly 2 million years ago, possibly later in some regions, which means at least some of them survived to see the first fully human relatives spreading across Africa. They didn't overlap, but they came within an evolutionary heartbeat of doing so, which is exactly the point our next 2 animals will make even more sharply, because the ones that come next we almost met. Go back to the ocean one more time, because before the ocean became the relatively manageable body of water we picture today, it had one last emperor. Its name is Otodus Megalodon. Most people know it simply as Megalodon. It is the largest predatory shark that has ever existed, and it disappeared on the geological timeline only very recently. The size figure that appears in most reconstructions is around 15 to 18 meters, 50 to 60 feet, with a weight that scales up to somewhere between 40 and 60 metric tons. That is roughly 3 times the length of a modern great white, and many times its mass. The teeth are what allow the reconstruction because sharks shed teeth continuously, and megalodon teeth are so common in some fossil beds that they wash up on beaches to this day. Some individual teeth are over 7 inches long. In museum drawers, they look like sharpened kitchen knives. The teeth also carry a very specific story because paleontologists have found megalodon bite marks on the fossilized bones of large whales, specifically on the vertebrae and flippers, which tells us what megalodon was hunting. It was hunting whales. Not the way a modern orca hunts a whale, in coordinated pack tactics against a very large but relatively defenseless target. Megalodon was hunting whales the way a great white hunts a seal, by charging up from below and taking off a mouthful of the animal per bite. Megalodon disappeared roughly 2.5 to 3.5 million years ago at the transition between the Pliocene and the Pleistocene. The current best explanation is a combination of factors: cooling ocean temperatures, the closure of major seaways such as the Central American Seaway when the Panama Land Bridge formed, the collapse of some prey populations, and, crucially, the rise of new competitors, especially the ancestors of modern orcas, which were faster, more social, and possibly more efficient at hunting the whales Megalodon depended on. It is worth emphasizing that no evidence supports the popular internet claim that Megalodon still survives in the deep ocean. The fossil record ends, and the teeth stop appearing in younger sediments. The animal is gone, but hold that timeline in your head. 2.5 to 3 million years ago, because that overlaps just barely with the earliest members of our own genus, Homo. The first Homo habilis, generally considered the earliest species in the human genus, appears in the East African fossil record starting around 2.4 million years ago. So there was a very short window during which some of the last megalodons were still swimming in a warming, retreating ocean, while the first tool-using human ancestors were chipping stone tools on the African savanna. They never met, as far as we know, but they existed at the same time. That is a strange thing to say about a nightmare. And it gets stranger because the very last animal on this list overlapped with human beings directly. Its name is Gigantopithecus blacki. It was a genuine ape, closely related to the modern orangutan, same broad family, but scaled up to something no living primate matches. The best size estimates, which vary quite a bit because most of what has been recovered are teeth and jaw fragments rather than complete skeletons, put Gigantopithecus at up to 3 meters tall standing upright and roughly 200 to 300 kilograms in weight. Some earlier estimates went higher, but current work has revised those numbers downward. Even at the conservative end, this was a great ape roughly twice the size of a modern gorilla. It lived in the bamboo forests, jungles, and mountains of what is now southern China, Vietnam, and northern India. And it was almost certainly a plant eater, based on the wear patterns on its teeth. But its plant eating didn't make it safe. A 3-meter ape, whatever its diet, is not a creature you would want to surprise. And here is the detail. The most recent studies of Gigantopithecus fossils suggest the last populations went extinct roughly 215,000 years ago, which is comfortably inside the timeline of anatomically modern humans in Asia. Early Homo sapiens, and definitely earlier Homo species such as Homo erectus, walked in the same forests as this animal. There is a strong case to be made that our ancestors watched Gigantopithecus die. Sit with that last figure for a moment, because it is the punchline of this entire documentary. 215,000 years is not a long time. It is not even a long time in human terms. Anatomically modern Homo sapiens have been on this planet for about 300,000 years, meaning we, as a species, existed for something like 85,000 years before Gigantopithecus died out. There are living human genetic lineages older than the Gigantopithecus extinction date, which means the last members of that giant ape were not fighting off dinosaurs or asteroids. They were most likely fighting off us. The going hypothesis for the Gigantopithecus extinction, in the most recent literature, is that a shift in climate reduced the bamboo and fruit forest habitat it depended on, and it was too large and too specialized to adapt. Human competition for the same forest resources may have accelerated that pressure, though the direct evidence, cut marks on Gigantopithecus bones, for example, of the kind we have for other Pleistocene megafauna, is limited. The animal essentially outgrew a shrinking pantry. Its body plan was too committed to a food supply that was going away, and it starved out, which is a much less cinematic ending than being killed by a spear, but it is a much more common ending in the fossil record. Most monsters do not die in combat. Most monsters die because the world quietly rearranges itself around them. That is the thread I want to leave you with. Because when you line up the 10 animals in this documentary, the Carboniferous arthropods, the Permian synapsid predators, the Cretaceous marine reptiles and pterosaurs, the Paleocene snake, the South American giants, the Miocene shark, and the Pleistocene ape, you notice something. None of them died because a bigger predator came along. None of them died because they were outfought. They died because the world changed. Oxygen dropped. Volcanoes erupted. An asteroid landed. Climate cooled. Sea levels shifted. Continents connected. Bamboo forests retreated. The mechanism, in every single case, was environmental. The monsters were not defeated. They were, quite simply, no longer supported by the ecosystem they had been built for. And that is what makes this a documentary, and not a highlight reel. Because the same mechanism is running, right now, on the species alive today. Habitat compression, climate change, ecosystem restructuring on a compressed timescale. The animals that stand in for these ancient nightmares today, the polar bears, the great whites, the tigers, the elephants, the whales, are, on the geological view, mid-sized and unremarkable. They are not the monsters. They are what is left after the monsters. And what is happening to them is what happened to the monsters. Environmental rearrangement, slower than a lifetime, faster than adaptation. The comfortable version of this story says, be glad these creatures are extinct because we would not survive them. That is true. If a Mosasaurus were still alive, you could not swim in the sea. If a Quetzalcoatlus were still around, air travel would be different. If a Titanoboa still lived in the Amazon, that river would be uninhabited for 1,000 miles. But the uncomfortable version of the story is the one I think you should take from this, which is that we are here soft, slow, hairless, upright, breathing air at 21% oxygen, only because a very specific sequence of extinctions cleared the way for us. Each of the 10 animals in this documentary is, in a real sense, a door that had to close before we could walk into the room. And if you find yourself grateful they're gone, that gratitude has a second half, and the second half is a question, which is, what door is quietly closing right now that some future species will thank us for closing? And what is coming through the one that opens? Thanks for watching this all the way through. If you found this useful, please leave a like and a comment telling me which of the 10 animals you'd least want to encounter. I read every one. And if you want more investigations like this, subscribe, and I'll see you in the next one.